Hello everyone, this is Sahil Garg of SD2S401. So today I will be presenting my Capstone project for Module 5, that is Applied Statistics. So basically we have 50 questions over here, and moving forward I will be explaining 5 of them. So just a minute. Yeah, sorry. So taking on the first question, I have taken 15th question as my first question to explain, which is what is probability theory. So probability theory is a branch of statistics, a branch of mathematics that helps us or tells us about the possibility of an event, the possibility of happening of an event. It helps us in analyzing the random processes and make predictions based on that data. So probability is always between 0 and 1, and the results getting 0, we can be very sure that the event is not going to happen. And if the probability is 1, that means we are very certain that the event is going to be happen. So the key concept in the probability theory, we can just sort it out them in four ways. First is the random experiment. So we take an experiment, very random experiment, any random experiment like rolling a die, flipping a coin, or taking anything, or taking a card out of the pack card pack. So that is a random experiment. Secondly, um, for every random experiment there is a sample space. That means how many possible outcomes are there. For example, in rolling a die there are six possible outcomes that we can get. That is 1, 2, 3, 4, 5, 6. Similarly, in taking out a card out of the deck, there are 52 possible outcomes, as there are 52 cards in a deck. This is called a sample space. Event is the possibility of a thing that we are asking. For example, if we are asking to find the probability of getting a number greater than 2, if we roll a dice. So greater than 2 number, we are having 3, 4 and 5 and 6. That means four numbers that there are that are greater than 2. Four numbers that are greater than 2. So the event will be 3, 4, 5 and 6. Now moving on to probability. Probability is the calculation of the favorable number of outcomes. The event, when we take the event, we find out the favorable number of outcomes, and we divide it by the total number of outcomes, and the result will be coming between a value between 0 and 1. So examples of probability we have: probability of an event will always be between 0 and 1. It can be either 0 or 1 also, no problem in that. The probability of a sample space is always 1. If we calculate sum of all the probabilities of the event, the it would come out to be 1. For mutually exclusive events, if events are linked to each other, the sum of their probability is 1. Conditional probability is, if we have to find out the probability of a event given that a second event has occurred, that is conditional probability. That means a probability that is based on a certain condition, that is called conditional probability. Independence is finding out the probability of two events which are totally independent of each other. That means if one event happens, that does not make any impact on the first event. Thank you. Moving on the next question, we are having what are the primary components of the probability theory. So the primary components can be divided into 12 major parts. First is random experiment. So random experiment is, as I just told you earlier, random experiment is taking on any experiment, any process, any event that we want to have, so like rolling a die, flipping a coin, drawing a card from a deck, or taking out a ball from a bag. These are all random experiments. Next is the sample space. Sample space is what are all the possible outcomes for the random variable that can have. After sample space, we have events. Events is the total number of specific outcome or a collection of outcomes. For example, rolling a dice and we want to have the even number. So the event would be 2, 4, and 6. And similarly, we have to find if we have the odd number, then we will be having 1, 3, and 5. So events are the things that could happen for a certain type of uh, equation. Next, the probability measure. The probability measure, as we have already understood in the last question, probability measure is the measure of the probability which would be coming between 0 and 1 for any event. If probability of an event is 0, that means the event is impossible. If the probability is 1, that means it is a sure event. And between 0 and 1, it means we can find out the probability of the particular event. For mutually exclusive events, for example, if there are many events, the A1, A2, A3, A4, the sum of all the events, if we sum all the events, the sum will come as 1. Conditional probability. Conditional probability, just a minute. Now, having conditional probability. Conditional probability is the probability of an event given that the other event has occurred. The formula for this is P A. Just a second. So the formula for this P of A and B will be equal to P of A intersection B divided by P probability of B. So here, as we can see that this represent as the the P of A upon B is the probability of A happening if B has already occurred. Secondly, P intersection B is the probability of the events which are happening in A and not in B, which and when divided by probability of B. So that is how we calculate the probability of conditional probability of A and B. Independence is the probability of two events if the probability of one event does not affect the probability getting the probability of the second event. The formula for this is probability of A intersection B is probability of A multiplied by probability of B. For example, flipping a coin twice. So if we flip a coin twice, the outcome of the first flip does not influence the second. If the first flip is heads, second could also be heads or the second could be tail. So the first one does not have any impact on the second outcome. Seventh is the random variable. Random variable is the possible values of outcomes on a random phenomena. These are of two types, discrete and continuous. Discrete is the countable number of values. That is, if we want to count the number of heads by flipping a coin, that means we can count the number of heads. Either it will be one head or one tail. In continuous, we can't count the number of values. For example, if we have to find out the height which is less than 180 centimeters, so there are infinite number of people which are less than 180 centimeters of height. So that is continuous variable in which we cannot count the number of values. It is a probability distribution. Probability distribution describes how the probabilities are distributed over our values of the random variable. These are of two types, discrete and continuous. In discrete, it is of two types, binomial Poisson, and continuous is normal, uniform, and exponential. Expectation is finding out the average of the value of random variable over a long term. For example, if we want to find out the probability of getting 3 when we roll the dice 10 times. So for example, we get 3 times, so probability of getting 3 would be 3 upon 10, which is not equal to getting the uh, probability which is 1 upon 6 of getting 3. So if we continue to roll the dice 1000 times, 2000 times, we would be getting close to 1 by 6. So in the long run, the average value of the random variable of the many trials is called the expectation or expected value. Now the variance and standard deviation. Variance is the spread of random variables around the mean. So variance is how much values are spreaded across the mean of the values. Standard deviation is just the square root of the variance. Bias theorem. Bias theorem is the probability of an event in which we know that it is dependent on the second event. It is known as the bias theorem. Probability of A of an event A given that B has already happened. That is Bayes theorem. Formula is probability of A upon B is equal to probability of B upon A multiplied by probability of A into probability of B. 12th is a joint and marginal probability. Joint probabilities are probability of two events occurring at the same time. Marginal is probability of single event derived from the joint probability distribution. Law of total probability is if the all the events are mutually exclusive, then all the sum of all the event would be equal to 1. Central limit theorem states that the sum of the large number of independent identically distributed random variable approximately normal distributed. that center limit theorem is if we take the large number of independent variables, it would be normally distributed. Moving on to our next question, what is conditional probability? Conditional probability is simply, in a very simple uh, words, we can say that occurring of a event A with the condition that event B has already happened. It is denoted at P A upon B, and it is calculated using the formula P A upon B is equal to P A intersection B upon P of B. For example, let's take an example. Event A is getting an ace from a deck of card. Event B is getting an face card. Probability of probability of B would be face card are total of 16, 4 in each. That means 16. So it would be 4 upon 13. Probability of A intersection B would be 4 upon 52. As A is ace. So in each face card we have one ace. So four total four of this. So we have four ace card. So A intersection would be 4 upon 52. That is 1 upon 13. P of A and B is putting in the formula. It would be 1 upon 13 upon 4 upon 13. That would be 1 by 4. So this is called conditional probability. That means if we are getting a face card and we have to get an ace after that. So getting an ace from after getting an face card would be 1 upon 4. Question number 18, what is Bayes theorem and how it is used? Bayes theorem is the fundamental thing, and we know that it is the probability of event A given that the probability of that the event B has already happened. That is Bayes theorem. Bayes theorem is find the probability of a event A if event B has already happened, and we have an evidence regarding that. So now, let's take an example. For example, a factory is producing three machines, using three machines, sorry. A factory machine A is having 30% of the production, machine B 20%, and machine C is 50% of the production. So the production probability would be 0.3, 0.2, and 0.5 for A, B, and C respectively. We are given that out of all the products that are produced, 5% are defective. That means defective products out of A would be 0.05, out of B would be 0.03, out of C would be 0.01. Out of all products, the machine A is producing 5%, the B is producing 3%, and C is producing 1% defective items. So we are selecting an item as at random, and it is found to be defective, and we have to find out the probability that it was produced from machine B. So the thing is, we have taken a random product and it is defective, and we have to find out that the product that was selected at the random was defective and was produced from machine B. So using the formula, probability of machine B over defective would be probability of getting a defective piece from probability from machine B multiply by machine B divided by probability of defective piece. So probability of D over B is 0.03 multiply probability of B is 0.2 upon probability of D. Probability of defective piece will be calculated by total probability theorem. The total probability theorem says that probability of D is equal to probability of D over A multiplied P of A, probability D over B into P into B, probability D into C into P into C. Putting the values, we will be getting 0.026. Now putting in the formula, we will be getting probability of defective piece getting out from the machine B would is 3 over 13. So this is how we use the Bayes theorem. Moving on to our next question, we have the question number 23. What are the some of the common measures of central tendency and how are they calculated? Central tendency can be distributed in three parts, that is mean, median, and modes. The main work is to provide some summarization to the data. So first is mean. Mean is the arithmetic average. That means the sum of all the data points that are giving divided by the total number of the total number of the points that are in the data set. For example, the sum of the average of all the of 10 points that are given in the data sets is 50. So there are 10 points, the sum is 50, so the mean would be 5. Median is the median value. Median is the middle value of the data set. If the data set is even, so the median would be getting, for example, the data set is 10 data points. That means the sum of the fifth and the sixth terms would be coming out to be the median. And if it is the data set, the number of counts is odd. So the middle term, the n upon 2, n plus 1 upon 2th term will be the median. Mode is the most number of occurring data. For example, there are 50 points and 3 is coming 14 times, and it is greater than most all the number that are occurring repeatedly. So the number which is occurring the maximum times in a data set is called the mode of the data set. Thank you. That's all from here. Thank you.